Hi everybody, welcome back to Shroud Man's Shop. I am the Shroud Man. What I'm going to do today is just, I'm going to show you a modification I made to my lathe that was born from an idea based on something I saw at another fellow's shop. I had gone there to get a piece of wood. No, not that kind. A big piece of walnut that he had. And I saw on his lathe that he could turn at a speed of about 2 or 3 RPM. My lathe won't go below 250, but it will now, because I decided, first I decided I would get a new speed controller, and after doing some research with people who supplied speed controllers, one of the first questions they asked me was, is the fan on your motor okay? And I said, well, I don't have a fan on my motor. They said, then we advise you to not slow the motor any more than it will go already, because you could have an overheat and just burn your motor up. Well, I'm not prepared to do that. So after beating my head against a wall for a while, including looking at new motors, I said, well, that just put me right back to where I was. So I decided that I would add a second motor to my lathe. And that is exactly what I have done. And I can now control the speed of rotation of my chuck down to about a half an RPM if I want to go that low. Actually, I can go right down to 0. But I've been using this, my stronghold chuck from One Way, as a test weight on it. My stronghold chuck weighs 8 pounds. From what I can understand from the specs on the One Way site. So I'm thinking that if I have a bowl on this chuck, it's probably not going to weigh more than maybe a couple of more pounds. So I could be looking at roughly 5 kilograms in total. So what I did was I cobbled together a series of parts that some I had kicking around the shop from other projects, some I had kicking around from pieces I collected here and there, and a couple of pieces I had to order from, well, I ordered from Amazon. And if anybody's interested, I'll try and put a link to those pieces down below. So what I did was I ordered some pulleys that were originally designed to go into printers or 3D printers even, and the corresponding little toothed belts, timing belts as they're called, and I've attached them to the far end of the lathe. I'll show you all of this before we go, and it's working just fine. I'm happy with it. And the only thing that I thought is, if I try to turn this lathe with the belt still attached, it's going to tear that belt to pieces. It may tear my little motor to pieces. We don't want that to happen. So I had to come up with a way to disconnect the belt fairly quickly. And what this video is really going to be about is how I sort of kludged it all together, and what the net result was. If any of you want to try this, feel free to get in touch with me. I'll give you any other additional information I may have. But also, if you want to kick some ideas past me, I may have already thought of it and rejected it, or if you guys have any additional ideas that will help me improve mine, well, I'm listening. So anyways, let me get set back up onto the far end of the lathe here on the headstock, and we can start to talk about how I put it together. And I didn't lose any blood, so it never actually tried to kill me. But I had a lot of fun actually sorting it out. So anyway, without further ado, let's have a look at the mechanism. First of all, this is the top pulley here. This is the bottom pulley. And this is the little timing belt that attaches them. This little motor here was originally designed and built by, I assume, a China company. And it was originally built to turn 30 RPM, 30 revolutions per minute. And I had bought this thing to make my snowblower chute turn. And it would have worked fine, aside from 30 RPM is not enough torque to turn the chute. So I replaced it with the exact same motor that was 10 RPM. And it has ample torque to turn the chute. So I thought, well, I've got this thing laying around anyways, so let's see if we can adapt it. So I started thinking, if I reduce the speed, I should be able to increase my torque. So this has a torque reduction, according to my math, based strictly on diameter. This has a torque, it has a speed decrease of 4 to 1. So I thought, conversely, that should give me a torque increase of 4 to 1. So this little motor here, even if you grab it with your fingers, the shaft, when it's turning, you can't stop it with your fingers. So I thought, that's pretty good. So if I increase the torque by a factor of 4, this should quite easily turn this big chuck, or a smaller chuck with a bowl in it, or even this chuck with a bowl in it. So what I was left to try and do was figure out how to mount this, how to mount the little motor, but still be able to take this belt off of here quickly. So what I did was this spindle has inside it a hex. It's meant to take an Allen key. So I measured the Allen key that comes with the lathe, and it was M12, metric 12 millimeter. So I found a coupler in well, on Amazon. And I've got an extra one here. Let me show you. Okay, here it is here. And you can see it's threaded inside to M8, metric 8 millimeters. So I had to find a way to adapt that to this. Well, that was not that big a deal. The hole in this pulley was smaller, so I drilled it out. And that was, gosh, I forget what diameter it was. I can make a note of that later on. And I did the same thing with the smaller pulley. So once I started adapting these together, it dawned on me that I had a difference between where it was attached to the original spindle knob and where this motor pulley were. Well, and if you do any mechanics at all, you'll know that these belts have to be aligned pretty much dead on, or they're going to kill themselves or come right off of the pulleys. So what I did was I took a little piece of cherry that I had laying around in the shop, and I put it on the lathe and I spun it, and I made it in a way that would fit inside of this and yet still be flush on the back side of this pulley. I'll zoom in that a little bit for you here. The next thing is I'm thinking, how the heck am I going to mount this motor and still be able to adjust the tension of this belt? So what I did was I used it's called by electricians a two-hole strap that they use for attaching solid conduit, EMT, to the wall. And 1.25 inches was virtually identical to the diameter of the little motor on this. This is a gearbox in here, and the motor's on the bottom. So I said, well, I want to be able to adjust it up and down, so I want to be able to tighten it. So I just drilled some holes from the back. I used 2 carriage bolts, 1/4 20 carriage bolts, and I put some wing nuts on them. I'm enough of a wing nut as it is, but 2 more won't hurt. And how I mounted this piece of plywood was from 2 existing holes that were already in the I don't know what the heck you call it, the frame of the lathe. This is where the ways attach here, or these are the ways, and this is just below. What it was a little holder for tools that came with the lathe. I took it off. I'll find another way to remount that at some point. And there's also a cover plate that's down here, a little bit below the motor, and it had a little handle on it for removing the cover plate. Cover plate's just to cover up the hole in the end of it and cover the lower pulleys for the spindle. So I'm not worried about that right now. I can decide what I'm going to do with that. And the leads for the motor come out right on top of that, so that's why I had to take it off. But anyways, this little piece of plywood is just something I had knocking around, and I thought, well, this strap and these wing nuts will hold the motor just fine, but how am I going to adjust the tension on it? So I hit this idea. It's just a 90-degree L bracket that I got from the hardware store for about like $1.50, I don't know. And I just opened up the one hole. I cut this a little bit shorter because I didn't need it sticking out another 1/2 or 3/4 of an inch. And I just set a nut. This is a 1/4-20 screw, 1.5 inches, and I just put a 1/4-20 nut underneath it and threaded it in, because I realized that if I want to push down on this motor, I don't need to attach this nut to the bracket. Just me tightening the top of the nut, or tightening the screw down onto the motor to tension it, will take and pull this nut up, and the two will work against each other, and they work just fine. So I mounted the bracket to this piece of plywood, and I used 2 screws. One I brought in from the back, the other one's just a flathead number 8 by 1/2 inch screw that I screwed in from the front, and the idea of using 2 is just to keep it from twisting, so it's not going anywhere. Now electrics. This little motor is 12 volts, and it draws, not very much, a few milliamps. I'll try and get the spec on that for you if I can, but I'm using a little power supply that I had laying around, and it's 12 volts, and it's I think 3 amps, which is tons for what I want. It's probably like 1,000 times more than I need, or more likely 10 times more than I need. But anyway, it works. It works great, and I'm more than happy with the way this has turned out so far. I may still tweak it a little bit, but I mentioned this to a few people, and they said, geez, why don't you make a video and put it out, because other people may be interested in this. This thing here hanging off the side, it's just called a lynch pin, and I used that. There's a hole through the original spindle knob, and what I did was I took my coupler and I set it in place, and I marked it's about there in respect, and I drilled a hole through it, and when I put it in place, my lynch pin goes straight in and straight through, comes out the other side, just by a little bit. And once I put this spacer, the cherry wood spacer in here, it pulled it in tight. The lynch pin doesn't want to come out unless I want it out, and it holds this pulley firmly into the old, like the existing knob, and takes any wobble out of it. When I first started playing with it, I had so much wobble that the belt would come off. But once I put that spacer in and took up the slack, this thing is solid, like you could probably hit it with a hammer and it wouldn't go anywhere. So, although I'm not going to try it. This will have ample other ways to try and kill me, I'm sure. So this motor and gearbox is normally built to to turn 30 RPM. And I thought, with my intended reduction of 4 to 1, I should get down to about 7 RPM, a little more, 7, 8. So when I first ran it up, I set my timer on my phone to time me for 1 minute, and I just looked at the jaw number. I started with number 1. I hit timer, and I just counted the number of times I saw 1 come around until I hit 1 minute, and it was about 7.7 or 8 by my guess. So my numbers were right. And I tried to stop this, and I can't actually stop it. But I can stop it, but what happens is the teeth on the belt start to jump. So if I ever get too much weight on here, that's exactly what's going to happen. Now, to make matters more interesting, I still have this ready. I haven't decided how I'm going to route the cables, but I got this little speed controller, also from Amazon. It wasn't very much, 20 bucks or something. I can put the model number if anybody's interested. And these are currently the leads to the motor. This is the lead to the power supply, the 12-volt power supply. And this has a stop. You can maybe hear it click. And up at max, well, it gives me the equivalent of 7 RPM or 8, whatever the heck it is. So what I plan on doing is mounting this into another little small project box, and I'm going to also incorporate a reversing switch where it reverses the motor leads, so I can make the whole thing turn backwards if I want to. This lathe will turn backwards anyways, but I want to be able to turn it backwards for polishing or whatever I want to do to the bowl that's on here, or whatever, spindle, whatever it happens to be. So that's really how this whole mechanism came to be. And I'll show you it turning. And like I said, I'm quite impressed with how I was able to reason it out. I did things like this, modifying stuff over the years as part of my career. So it wasn't that much of an afterthought for me to turn my attention to my lathe. So we'll show you a few more pictures here, and we'll just we'll put it on YouTube and see if anybody gets a kick out of it. So anyway, I'll show you some pictures of it working, and a few more fantasy things. All right. Okay, you can see in here, this is the little cherry spacer that I made to adapt it one to the other. Right here is the bottom end of the linchpin that holds the whole thing together. And you can see it's nice and solid in there. So I've got it hooked up. I'm going to try and show you this thing working. It's turning in reverse now. I've got it slowed right down to 0. This is the top end of a linch pin. If you don't know what a linch pin is, it's meant for mechanics. It's generally used on tractors. And when you put this pin in, if you flip this thing down so where it's kind of parallel to the actual pin, it doesn't lock it in, but it gives you a way to pull this thing out without it sticking out in the middle of nowhere. And for me here, I don't care. I can pull this thing off if I care to. But I thought it's easier to put in and out. So what I'm going to actually do when I want this thing off of here, because like I said, if I try to turn the lathe with this thing on it, it's just going to tear this belt to pieces, and maybe even the motor. And we don't really want that. But if all I have to do is loosen these nuts up, back this screw off a little bit, and this belt will come right off. I'm not worried about turning this with the big motor to the lathe connected. Generally, if you fight two magnets, you'll get something called back MMF, back magnetomotive force. And I don't want that to happen, but this is turning so slow, it's not going to generate a magnetic hysteresis in my big motor, I don't think. So we'll find out the hard way probably, but anyways, we'll if you just keep your eye on the big chuck, or even here, that sound you may hear is the little motor, the gearbox in the little motor. It didn't make that until I decided to take it apart. And now we're at full speed. And again, the reason behind doing this is I wanted to be able to put a bowl on there and apply finish to the bowl while it was still turning, because I have a rough time trying to turn it by hand with my left hand and apply finish with the right hand, that is. So I figured if I can get this turning just slow enough, I can do that by itself. And the fellow that showed me his, was showing me his, and what he does is he applies finish, and then once he's done applying the finish, he just lets it turn on there for a few minutes. And it stops you from getting drips and runs and just spots where the finish may want to collect, and it just keeps it rolling around until the finish starts to set up, and then you can shut the thing off. He says it doesn't usually take very long, but I thought, what a great idea, and that's how it came to be that I was going to come up with this crazy scheme. So anyway, I think that's all I've got for you. And if it decides to self-destruct, I'll put another video out. So you see, that's down to 50%, so maybe 3 RPM. I guess it depends on how good the gradient is on this little speed controller. So and let's see, I can turn it right down to 1 RPM per month. I don't know. So anyways, there it is, and I hope some of you other turners get a kick out of it, or maybe even anybody that doesn't turn has an application for something like this. And like I said, if anybody wants to contact me to get any more ideas or what I came across in the way of problems as I was doing it, I'll gladly share all that with you. So thanks for stopping by Schroedman's shop, and I hope we'll catch you soon. I'm thinking about doing a video just with pictures I took of stuff that I've done in the past months, and once I get a chance, now that the summer's months are over and it's just turn, I'll maybe be able to put a video like that together. Thanks again. Please like and please like and subscribe and share. And seeing as how it's nearly the end of the year, happy holidays to everyone.